I'm from another data competency center. And there I am advising people who want to apply machine learning with their collection data. And I was expecting to do much more classical computer vision-based research, but it turns out 80% of the people who work with collections mostly want to do OCR, and they mostly want to do OCR on structured records, like inventory cards. So this is what I will be presenting. It's very much a work in progress, so please be kind. If it's not perfect, it is not perfect, but we are still working on it. If you want to follow along once we are at the demonstration of the tool, you can certainly do that. What you need is a Python installation and some knowledge how to use the terminal, but it's not much. Now, let's jump right into it. So this is about reading inventory cards. And as I already mentioned, it's work in progress, meaning that the system that we have right now presupposes a very fixed layout. It also presupposes that this layout is not tilted in any way. This can be changed later, but for now, this is the use case. So this is basically SODa, the other data competency center, and the World of University collections. I would like to quickly show the project that the OCR tool was actually developed for and how that works in this respect. And then I did some experiments to see how traditional OCR compared to large language model-based document level understanding, how that performs. And I would like to give a bit of insights of what's the difference, first of all, and the performance difference with the data that we used for the research project the tool was developed for. I was quite surprised when I started working with SODa how many collections of university there are just in Germany. It's more than 1,400 and roughly 130,000 universities. That's a huge diversity also in terms of what disciplines are covered, the kind of objects, and some of them are really huge, mostly actually the botanical ones, because they are seed banks, they have millions of samples. And then you also have very small collections where people who worked maybe in one department just collected stuff that they used for teaching over the generations. And they have, I don't know, very small scale, but it's also sometimes very interesting data. And in general, collections, it's important to safeguard somehow the history of science. So if you know what has been deemed valuable for collecting or for keeping, for archiving, then you also know what has been important in these disciplines, right? And then, of course, because it's university collections, it's also objects that have been used in teaching. So if you look at these objects, you will also learn something about how teaching might have worked, what was considered interesting enough to teach to the students. It's also just a valuable wealth of resources for research, but there's a big problem that these collections are not very well known and they're underfunded. They don't have enough personnel and they are not very well connected. So this is why SODa was brought to life. Most important for us here is probably the 2D and machine learning area of expertise, because this is what I am doing. And the Kupfer research project is a project at the Lehrmittelsammlung Pforzheim, the Hochschule of Pforzheim. They approached us because it's a university collection and they have many inventory cards that they wanted to digitize. They are focused on design and they have a really cool collection of mostly teaching materials, and it's very diverse as well. They have jewelry, diapositives, design objects, even stuffed animals. And they have this research project that's called Kupfer that basically focuses on researching the collection and what you can learn about historical interplay between design and craft, also how it was actually taught, learn stuff about how there were connections to different centers of jewelry. And they also research the provenance of some of these objects. Most importantly for us, it entails the digitization of their collection, which is somehow a basis to really actually do large-scale research and also do some big data or more data-informed way of approaching these questions. This is why they approached us. They were basically the first ones. What we could do is we could develop this tool in close collaboration with them. And for us, it was very cool because we could consistently get some feedback. And for them, of course, they had someone who could solve their problem. The workflow is split into 5 steps. First of all, the cards have to be digitized, and then we configure the layout, and we just have to run the script. But of course, the results are not yet perfect, so you also have to clean it up. And this is where they used OpenRefine. And in the end, they upload their data to Museum Digital. This basically gives them the requirements for the data fields and also how the fields have to be interpreted. It somehow makes things a bit more complicated because it's an event-based ontology, meaning that you actually have to do some interpretation at some of the fields. And then as a side note, on the inventory cards, they usually have some photographs, and we need to detect them to be able to crop them afterwards and upload them to the database and map them to the respective metadata fields. This is one of the cards where they basically annotated all of the fields. The good thing is, as you see, most of it is actually well readable because it's machine written, and it's also super well separated, right? Sometimes you do have overlapping text, but most of the time it's quite clear where each part of the text belongs to. This is why a relatively simple script could solve their issues already. Now there are two approaches for modern OCR that you can try to do. The first one is on the left, is basically the assumption that I've already mentioned, that we do have a fixed layout. We can define coordinates for each of the fields, and then we can assume if we define that for one of the inventory cards, we will have each scan with the same coordinates, meaning that we can just do the OCR, detect where the lines are, which is part then of the traditional OCR method. And then depending on the coordinates that we get for this line detection, we can assign the recognized text to database fields. This works as long as you have this fixed layout. There's also some layout or layout understanding where you don't have this extra step of detecting lines. You could consider this document level OCR, and it's newer state-of-the-art methods who do it this way. You input the complete document, and then you have an output which usually comes with a text decoder, like a LLM-based stuff, where you just sequentially output each of the fields in the input document. And that means that the model itself has some implicit understanding of how to interpret each of the fields, and it gives it some flexibility with respect to the layout, etc. So if you have some tilting, shifting, and so on, you don't necessarily have to correct for that 100%. But the downside of that is that it's way more difficult to host models on your own. The alternative, of course, is that you can just use paid services. And also, you have to send your data somewhere. You are dependent on someone else. And we actually want people to be competent to do the complete process without having to rely on external services. This is from the homepage of OCR for All, a short visualization of the typical classical OCR-based workflow where you have some correction of the orientation of the images. This is a part that basically is still missing in the script that we will be looking at, but that might actually fix some of the issues already. You usually have some segmentation of where text fields are, where also images might be. And then you have a segmentation of lines. And that's a separate model. Once you have the lines, you have a separate model, which only the OCR. And that is opposed to document level OCR, which I described before. This is a visualization from a paper from France, where they basically learn a hierarchical tree of the layout. It's called DAN. And then they implicitly assign each of the recognized text to each of the fields in this document hierarchy. For simplicity, I was using a Mistral OCR in my experiments. It is a European company, and it's also quite good with OCR. And then we did some experiments with the data that we got from Kupfer. This is all without fine-tuning. So we tried two different approaches for the traditional methods, which are here focused on lines. And then we have Mistral OCR as one representative of the newer way of targeting the complete document at once. We evaluated on a data set of manually annotated images. From the inventory cards, you can see the differences in the character and word error rates here. These metrics seems quite high. It also is quite high, but it looks a bit worse than it actually is because this is part of the evaluation protocol. Usually, if you compute these metrics, you will just look at the specific lines, line by line, and that presupposes a knowledge where the line already is. In this case, we are actually evaluating per field because the mapping to the respective database output field is part of that metric. So that makes it a little bit better than it actually looks. And in the character error rate, you do see a large difference if you take a paid service like Mistral OCR. But in the word error rate, it's very close actually. And considering that most of the time you would have to correct every word anyway, I think it gives you a good incentive to just use something that you can actually host yourself. Usually what you would do is, if you have a larger project, you would take part of the data and then fine-tune your models to basically recognize the fonts or maybe the handwritten parts, and that makes it much better. So this is out-of-the-box performance. So even with these relatively simple data, there are some challenges. This, for example, is not really an OCR challenge, but it's still something that's part of the complete pipeline, where if you want at the end to put this in a database, you don't want to have 4 different entries for Julius Heinrich Jeidels, because he has been written in 4 different variants in your inventory cards. You have to do some disambiguation. And then, of course, you have handwritten notes. This is relatively good for this data set because most of it is actually machine written. But the parts that are handwritten, they are also from different writers, which makes the whole process much more difficult, because if you want to fine-tune for one specific writer, it might not work for the other one. So that complicates things significantly. Something that comes after OCR is the semantics of the field. This has to do again with Museum Digital, or specifically the interpretation of what you will find in each of those fields. Most of the time, it's not enough to just put a complete string for each of the fields that you will have in the inventory cards. But if you want to connect the data, you will have to have some understanding, and you also might want to map this to, let's say, GND entries. So you want to have a linking to other ontologies. And here, for example, they have this erworben von, which is acquired by. And then depending on whether someone's being considered the creator or someone who is being considered the designer. So you have many different roles that you actually have to understand to assign that person and the acquiring process to a meaningful relation between the person and the makes things much more complicated. And this is where we actually need another layer of interpretation. And I think it's super important to really keep the raw output of the OCR as well as the source images. And also each step of the interpretation needs to be transparent, right? So all the steps that have to be taken before you interpret the data need to be available somehow. So people can do corrections, right? Because maybe your understanding changes. Maybe it becomes clear that, this interpretation process, whether it's done by rules or with an LLM, has faults. So this is something just to keep in mind. As already mentioned, it's currently optimized for data. It's not working perfectly, but it's quite easy once you have set it up to just try it with new data. It's open source, it's on GitHub. If you know a little bit of coding, you can easily adapt it. If we don't have it completely registered, there are classical computer vision techniques that make it quite easy to get this fixed layout if it's not exactly fixed before. And HDR is still a big issue. We also want to be able to include more different models. Now we only have these 3 options. And then fine-tuning, of course, is a large issue. I think it's very difficult to enable an easy access to fine-tuning in general. Transcribers does a good job, for example, and if we find a way, it would be nice to enable this somehow in our framework. Oh, Mistral OCR is also an LLM. So that is already integrated. And if you process large amounts of data, then you need an API. Basically, you need to access it via code. Otherwise, it's not really feasible for larger amounts of data. For just trying, you can just go to the chat interfaces, upload stuff. So this is for the chat bots like Claude, ChatGPT, and so on. But there are also LLM-like models which are specialized in OCR. And some of them also can be deployed on your own machines, right? So there's basically a spectrum of the autonomy that you can keep and that you can give away, depending on how much you want to invest in setting things up and how much you want to invest in paying someone else for doing that.